routing protocols like RIP, routing information protocol, or interior gateway routing protocol or exterior gateway routing protocol, OSPF. All these protocols manage the incoming and outgoing informations. In the last class, we already discussed about link state routing protocol and vector and distance vector protocol, link state and distance vector protocol. What is the link state? A link state is based on the link, number of the link. So this link state uses OSPF and IS, and other things is the distance vector routing protocols. In distance vector routing protocols, the routing table maintains the weight, okay, the vector distance, maintain the vector distance of the neighboring routers. For the neighboring routers, okay. And let's see here, interior first in this routing protocol. In this routing protocol, RIP and interior gateway protocol, exterior gateway protocol, OSPF, IS, and BGP are there. Let's see interior gateway routing protocol. So interior gateway routing protocol is distance vector routing protocol developed by the Cisco for routing protocols across small and medium-sized Cisco networks. So we can use in the large network and also in the small network also, this interior gateway protocol. Corporate or a company so can use this interior gateway protocol, and it is proprietary, which required that used in this Cisco router. This contrasts with this IP RIP and IPX RIP routing information protocol, which are designed to the multi-vector network. So IGRP will route IP, IPX, DECnet, and AppleTalks, which make it very versatile for client running many different protocols. So clients can run this different types of protocols like AppleTalk or the IPX or DECnet. So nowadays we are using the common protocols like TCP/IP, FTP, or any other like Telnet or HTTP. So all those are the common protocol used in the internet environment. In this in the olden days, there are different types of the protocols like IPX, DECnet, and AppleTalk. All those things having their own different protocols. Okay, so it is somewhat more scalable that RIP, since it supports a hop count of 100, and advertise the routing table. It is at every 60-second interval, so it's share the informations using the different metrics. Okay, different types of metrics. So IGRP advertise means share the informations. Okay, share the informations. Less frequently, it's used less bandwidth than RIP, but converges much lower since it is 60 seconds before IGRP routers are aware of network topology changes. In IGRP does recognize assignment of different autonomous system and autonomous systems and automatically summarize a network class boundary, as well as is the options to load balance traffic across equal or unequal matrix cost plan. So IGRP, interior gateway routing protocol, having the options to have a load balance across the network, equal or unequal matrix cost path. Matrix cost path means that we have a weight to communications distance weight, the cost, distance cost, okay, cost. So this will maintain by the routing tables. Okay, let's see the characteristics of this IGRP. This is the distance vector. Routes, it can route IP, Ethernet protocol also, IPX also, .NET and AppleTalk. Routing a table advertised every 90 seconds. And bandwidth, the matrix maintains this routing matrix. Contains the following informations: bandwidth, delay, reliability, loads, MTU, and also hop count of 100, and it is the fixed length subnet marks. There is no variable subnet marks. It's fixed the subnet network. Summarizations of network classes. Summarize the different types of network classes. It's maintain the load balancing across 6 equal or unequal cost path. And matrix calculations. This is calculated based on the destination path, minimum bandwidth and delay per seconds. Okay. And a split horizontal timer. There are different types of timer: invalid timer, 270 seconds, plus timer, 600, and hold down timers, 280 seconds. So there are different types of timer to maintain the connections, to maintain the connectivity. So in this interior gateway protocol, we have different types of important points. Okay, important points. Then let's move on important points and characteristics here, and let's move on to this enhanced interior gateway protocol. IGRP is the interior, simply this is the interior gateway protocol. If we say that's EIGRP, that is this the enhancement. Okay, this is the hybrid routing development by the Cisco router for many protocols across the enterprise Cisco network. So it's a hybrid. Yeah, it's a hybrid routing developed by this Cisco routing system to support many routing protocol across the enterprise or company. It has characteristics of both the distance vector protocol or link state protocol. So as the name suggests that this enhance the interior gateway routing protocols in both the vector and link states. It is a proprietary which requires that you use Cisco routers. EIGRP will route the same protocol that IGRP routes. So it can work in this in the EIGRP, Enhanced Internet Gateway Routing Protocol. Inside these routings, it can manage the protocol like this IP and IPX and DIGNET and ARPUTO protocols routed by the IGRP, Interior Gateway Protocol. So this enhanced protocol is very powerful as compared to this internet interior gateway protocol, and use the same composite matrix of the IGRP to select the best path destination. So it uses the same matrix, composite matrix, to select the best path, to find out the best path of this. As well, there is the option to load balance traffics across the equal or unequal matrix cost path, and summarizations of the automatic at norm network class addresses. However, it can be configured to summarize at the subnet boundaries as well. This is almost same with this IGRP. However, it can be configured to summarize at the subnet boundary as well. Then there is redistributions between this IGRP and EIGRP is automatic as well. There is support to a hop count of 255 and variable length subnet mask. So there are some difference in this EIGRP. So in IGRP we can have 100 hop count, and this is fixed length subnet mask. But in the enhanced internet gateway routing protocols, it is 255 hop count and the variable length subnet max. There is no fix in the subnetwork. Okay, these are the things in the enhanced internet gateway routing protocols. And let's move on to this characteristics. This autonomous system and same thing, no need to go in deep. This autonomous system also, it's elaborated from this EIGRP. Okay, let's move on to the characteristics. Number one is the advanced distance vectors, and it's route this IP and IPX and DIGNET and ARPUTO. Routing advertisements, partial when routing changes occur. Then matrix bandwidth, delay, reliability, load, MTU size. MTU, if we say this MTU, this maximum transfer unit maintained by the network equipments, maybe a switch, a managed switch, or maybe routers. Okay. MTU, maximum transfer unit. The maximum data it can manage at one time to transmit the informations. Okay, maximum data. Bandwidth already there, reliability, delay, all these things, and load also. It's maintained by the MTU. This how many data throughput can manage. This is called the load. Okay. Okay, hop count is 255 as compared to this IGRP. That EIGRP is a variable length. And summarizations of a network class address. So it's summarized on the network class address or subnet boundary. It's having the subnet boundaries. Load balancings across 6 equal or unequal cost plan, and timer 180 seconds. It's different. Okay. With the internet gateway routing protocols, matrix calculations. This is the 256 delay milliseconds per milliseconds into 256 into the destination path minimum bandwidth. Okay. Split horizontals, same things, and multicast address of the two least significant bit. Okay, LSA. Address, okay, least significant address, multicast address of this 225.0.0.10. Okay, these are the exterior gateway protocol important characteristics. Let's move on to this open source part first, OSPF. This is the link state protocol developed by the open standard for routing IP across large multiple vendor network. For this open source part first is for searching the shortest path to reach the destination in the uh, router network, within the router network, routing network. And it is purely developed from the link state protocol, developed from this link state protocol, and it can route IP across large multiple vendor network, or in the enterprise or in the company, or it's also possible in the smaller network also. A link state protocol will send a link state advertisement to all connected neighbor of the same area to communicate route information. So it's send a link state and advertise, it's shared the informations, routing informations. Advertise, sending advertisement. Its link state will send this link state advertisement to all connected neighbors. So this is connected to the network, neighbor network, connected to the device, the host device. Okay. So these informations are are set to the connected neighbor network, and the same are to communicate route informations. Each OSPF enable routers, when started, will send hello packet to all directly connected OSPF. So the difference is that in the interior gateway protocol, it sends out this routing informations without having the negotiations connection establishment. So it's simply send out and share the info, advertise the routing tables, and also it's occupies more bandwidth, larger bandwidth in the network protocol. So in this OSPF, it does not simply advertise or send out the routing informations before sending out the informations. Then it's sent the it's maintain the connections. It's maintain the negotiation between this neighbor neighbor router. So it will send first the hello packet to all directly connected in the OSPF routers. That hello packet contain information such as the timer, router ID, and the subnet mark. So if we communicate to a neighbor network using this hello packet, that contains some data to make the negotiations between this router network and neighbor network and the host network. So based on this, the informations like router timers, what is the timer to sense the information from the host to the neighboring router, and router ID of the host routers, and the subnet marks. And if the router agreed on the informations, they become OSPF neighbor. Once a router become neighbor, then establish adjacencies of the exchanging link state database. So if there are some negotiation acceptance between the neighboring router and the host routers, after having this hello packet negotiation, Then with the consent, with the acceptance of the two routers, then it exchange the link state database. So in this link state database, they did not simply send the link state database. It's maintain the negotiations, it's maintain the connections between the host computer and the neighboring routers. Host computer, sorry, not a host computer, host router, my routers, and the neighboring routers. So after having this confirmation, then it shares those link state database. Routers on point-to-point and point-to-multipoint link automatically establish adjacencies. Okay, it's maintained the adjacencies automatically established. A router with the OSPF interface configure the broadcast and frame relay NBMA. This Ethernet broadcast and NBMA frame relay will use to designate routers and establish those adjacencies for exchanging the link state database. So maybe sometimes in the multi-point link, okay, it may be a broadcast or maybe a frame relays. Okay, let's see the area. OSPF uses a hierarchy with assigned areas that connect to a core backbone of routers. Each area is identified by one or more routers that have established adjacency. OSPF have backbone area zeros, stub area, not so stubby area, and totally stubby area. Area 0 is built with a group of routers connected to a designated office or by one link across the several offices. So in the OSPF systems, there is one OSPF backbone. Backbones means the main connections, the main connectors, and for the main connections is divided into the stub area and not so stub area, also totally stubby area. So stub and the stubby area and totally stubby area. So all those things areas are interconnected in the backbone area 0. So this is the main trunk connectivities for others subnetwork. Okay, for other subnetwork. So it's preferable to have all area 0 network connected with the full mesh using a Ethernet segments or a core office. This provide a high performance and prevent partitioning of areas such as routers connected to fail. Area 0 is transmitted area or all traffic from the attached area. So these are no need to cover in depth use in this the usage of this OSPF based on the area. Okay, let's go through this characteristics. This open source part first is the link state routing protocol. It routes the IP. Routing advertisements, it's advertised the routing informations, and it is the matrix. It is maintained the matrix based on this composite cost of each route of the distance. This is the interface speed per the interface speed, and the hop count. There is no limit for the hop count, and having this variable length subnet marks, and also summarizations of network class address and subnet boundary, and also its load balancings across 4 equal coarse path, not in a 6 equal coarse path, And router third part is the internal and backbone and ABR and ASBR. And the area is backbone and stubby and not so stubby, totally stubby area. And the LSA type is the link state address is the inter area and intra area and external area. Okay. And the timers is the hello pocket interval and deadline interval, and also having this multicast address also 224.0.0.5 and 224.0.0.6. Okay, and also having the interface type point to point, broadcast and non-broadcast and point to multi-point and loop back interface are there. Okay, these are the important characteristics of the OSPF, open source part first. And let's move on to the integrated system, integrated intermediate systems. So this IS routing protocol is a link state protocol similar to the OSPF that is used with large enterprise and ISP customers. So these intermediate systems integrated routing protocol is almost same with the OSPF based on this link state routing protocol, and it is compatible with the large enterprise and the ISP customer. And intermediate systems is routers, and ISIS is the routing protocol that routes packet between intermediate systems. ISIS utilize a link state database and runs the shortest path first using the Dijkstra algorithm. Dijkstra is the database, tree structure to find out the shortest path, to select the shortest path routes. Okay. Neighbor router are point to point and point to multi-point link established adjacent by sending hello packet and exchanging link state database. ISIS routers on broadcast NBMA network select a designated routers that establish adjacency with all neighbor routers on the network. The designated routers and each neighbor router will establish an adjacency with all neighbor router by multicasting link state advertised to the network itself. So using this IS router on broadcast and NBMA network, select this router, designated routers, to maintain the connectivity to all the neighbor routers. It's use the multicasting listed advertisements to the network itself. Okay, that may be a unicast or maybe a broadcast, then maybe a more than one connection links that it advertises those informations, link state informations to this network with the network itself, to all the neighbor with the network itself. This is different from this OSPF, which establishes adjacency between the DR and each neighbor router only. Okay, designated routers and each neighbor router only. And ISIS use the hierarchy area structures with the level 1, level 2 and routers. Okay, level 2 router types. So there are different types of level in this ISIS. Level 1 routers are similar to the OSPF inter-area routers, which have no direct connections outside its area. So layer 2 is the routers comprises with the backbones area, which connect different areas similar to the OSPF area 0. So there are two types of area. Number one area in the ISIS is that it is similar to the OSPF, that which have no direct connections to outside area. There is no outside area connections within the cluster, within the cluster of this internal area in the level 1 of the ISIS routers, that's interconnected within the area only. But in the level 2 router comprises the backbone. So this is the responsibility to this level 2 router is that it's comprised of the backbone. So it's interconnected, all this cluster of this level 1 then interconnected using this backbone area. Okay, backbone connections to all the level 1s routing routers, level 1 routers. So it's similar with this OSPF area 0 also. With ISIS routers can be this level 1, level 2 routers, which is like OSPF area border routers, which has connected with its area and backbone area. The difference with ISIS is that link between router comprise area borders and not the routers. Okay, it's having the area borders and not the routers. Each ISIS routers have a designated address. So ISIS routers having a designated address that is unique for the routing domains. So it cannot be replicated with this routing domains. It's having the unique address. Okay, unique address, and an address format is used, which is comprises of the area ID and the system ID. The area ID is the designated area of the system ID, is the MAC address. From address format it's used, which is comprises to the area ID and the system ID. The area ID is area number of the system ID and the MAC address of from one of the router interface. This is support to the variable subnet mask length, and which is standard with all link state. So ISIS assigns the routing process to a interface state, interface instead of the network. Okay, those things are the protocol used in routing environments. One more protocol still left. This is the RIP, routing information protocols. We'll do it in the next class. And BGP also, border gateway protocol. So we'll do up to these topics, up to this ISIS, then we'll continue in the next class.